Okay, so you have a chicken. Unfortunately, it's uncooked and you're really hungry, so you need to cook it. You don't have matches to make a fire and you don't have an oven to cook the chicken. What could you do?
Slap the chicken! Slap the chicken!
Wait, what? Slap the chicken? All right, let's have a look at that. What we would be talking about is converting kinetic energy to thermal energy. Now, this is actually pretty easy to do, right? So there are two main types of energy. You've got your kinetic and potential, okay? But within that, you split them up further, you've actually got 9 forms of energy. So 2 of them are kinetic and heat. Now, by kinetic energy, we're really talking about the energy of a moving object. So if you're going to slap the chicken, we're talking the movement of your hand. Thermal energy is heat energy. Okay, so we want to convert our kinetic energy to our thermal energy. Not a problem. We'll start with an equation for each one. We have for kinetic energy, there we go, is equal to half times the mass of the object times the square of its velocity. Okay, for heat energy, now wait, capital Q, what the heck? Yes, but take my word for it, that says heat energy, right? So Q is equal to the mass times the specific heat capacity times delta T. What does all this mean? Well, delta, the symbol here, delta, that just means change. So we're looking at the change of temperature. Okay, C is actually the specific heat capacity. In general terms, it's how good is the substance at absorbing heat, right? Like water has a very high specific heat capacity because it's really, really good at absorbing heat. If you want to put out a fire, put water on it because water will absorb the heat away. And if you don't have heat, you can't have a fire. Great. So in not quite so general terms, specific heat capacity is the energy required to raise 1 kilogram of the substance by 1 Kelvin or 1 degree Celsius. Okay, so it's how much energy is required to raise a kilogram of the stuff by 1 degree. Now, what is the heat capacity, the specific heat capacity of a chicken? I would have absolutely no idea, but that's okay. I don't need to have an idea because Earl already found out for me in 1983, and then he was backed up by Ryman and Villas-Ruiz in 2004. So if we have a look here, we see that, here we go, chicken has a specific heat capacity of 1.77. Now, we are not going to use that 1.77 because that is in kilojoules. And the SI unit for energy is just the joule. So what we're actually going to use is 1,770. There we go. So that's the number we're going to use, right? 177, but we're going to times it by 1,000 to get into joules, right? Cool. So going back to our equations, we can solve this. Let's make one thing equal to the other thing, right? So we'll convert all of our kinetic energy into heat energy. So we have, what have we got? Half mv squared is equal now to mc delta T. Now, the mass of the chicken is about 1.5 kilograms, right? And we've actually got 2 masses here. We should really specify which one we're talking about. So that's the mass of the chicken. This is the mass of my hand. Okay. What's the velocity of my hand? Well, I reckon for a decent slap, cover about a meter takes about 1/10 of a second. If you sort of say, do a slap and go stop, that's about 1/10 of a second. So let's say 1/10 of a second to cover 1 meter. So our speed is about 10 meters per second. Okay, a little bit rough, a little bit estimatey, but that's okay for what we're doing here. I mean, we're slapping a chicken to cook it, right? We're going to be pretty rough here, aren't we? Now, let's solve for V. How fast do we actually have to slap that chicken? Okay, so V equals what? Well, we started with mc delta T, but the M is C because it's the mass of the chicken. Now, I don't want half the velocity. I just want to get rid of that. I can dump it across the equals. Remember, we can dump something across the equals if we do the opposite, right? So on the left, that half, has been 1 divided by 2. When it's on the right side of the equals, it's going to be times by 2. I don't want this mass of the hand here, dump it across the equals, but of course it was multiplied by. So when I dump it across, it's going to be divided by. the mass of the hand. That's squared. I don't want v squared, I just want v, so I'm going to take that squared and I'm going to dump it across the other side of the equals, and the opposite, of course, of squaring is to take the square root. So there we go. There's my equation for determining v, the speed that my hand will need to move if I want to slap that chicken. Oh wait, did we say what delta T was? Well, a frozen chicken, let's say we need to get up to 200 degrees Celsius. I can't remember if I said that before. So delta T, 200 grand. Now, let's just write that equation again without all the mess around it. So we've got v is equal to the square root of 2 times the mass of the chicken times the specific heat of the chicken times the change of temperature. Divide that by the mass of the hand. Now we can put in our numbers. Well, we have the square root of 2 times the mass of the chicken is about 1.5 kilograms. The specific heat of the chicken is 1770. The change of temperature of the chicken, we want to get it up to 200 degrees Celsius. And if we divide all that by the mass of the hand, was 0.4. Did I show you that? I can't remember. Goodness me, what am I doing today? There you go. The mass of my hand is about 400 grams, right? So 0.4 of a kilogram to work in SI units. And we get an answer from that. Now, the way we get an answer, I don't know about you, but I'm not a math genius. I'm using a calculator. So we have 2 times 1.5 times 1770 times 200, whatever that equals. Let's divide that by 0.4 equals whatever that equals. Let's take the square root of that. And there's our answer, 1629.5-ish. So if we come back here, we had 1629-ish meters per second. Now, it is ish, it is rough, but there you go. There's the velocity that our hand would have to be traveling, right? 1629 meters per second. Now, how fast was my hand traveling? Roughly 10 meters per second. So we're going to have to really step things up a bit, right? Let's say I can't get my hand up to that speed, right, with a slap, because it's pretty fast. Let's just say we want to do a normal slap. All right, well, how much energy do we get from a normal slap? Yeah? So the kinetic energy of one standard little slap, half mv squared, is, what have we got? We've got 0.5. The mass of my hand is 0.4. The speed of my slap was 10 meters per second, so we'll square that. What's that going to give us? This will give us half of 0.4 is 0.2. 10 squared is 100. 0.2 of 100 is 20, right? A fifth of 100. So I'm getting 20 joules of energy from one slap. Cool. Okay, how much heat energy do we actually need? Well, let's look at that. We have Q equals mc delta T. Now, the mass of a chicken is about 1.5 kilograms. The specific heat is 1770 joules per kilogram per degree Celsius. And the change of temperature is 200 degrees. Okay, let's work that one out by bringing back trusty little calculator. So we've got 1.5 by 1770 by 200, 531,000. Okay, so we need 531,000 joules of energy. That's an issue because my slap only produced 20 joules of energy. How many times am I going to actually need to slap the chicken? I produce 20 joules of energy. I need, to get this chicken cooked, I need 531,000 joules. Goodness me. Let's work that out. 531,000 joules of energy divided by 20 joules of energy per slap. That is going to, this implies, where's my calculator gone? This is quicker than working it out myself. 531,000 divided by 20 per slap. 26,500 slaps. Goodness me. I have to slap my chicken 26,500 times in order to cook it. Wow, that's a lot of slaps. Now, the thing is, I'm actually going to need to slap it more than this because this is assuming that all of the kinetic energy got converted into thermal energy. Realistically, That's not going to happen because it's going to make a noise when I slap the chicken. I'm going to be converting some of that kinetic energy into sound energy. So I actually won't get 20 joules of energy produced per slap. I'll get less than that because some other energy was wasted as sound. So there you go. There's the physics of it. Slap your chicken 26,500 times to cook it. Realistically, you'll have to slap it more times than that. If you don't want to slap it that many times, just give it one big slap. But that big slap will be 1,600 meters per second speed. Crazy. But there you go. Cook a chicken by slapping it.
Don't forget to hit the like button. Yeah. And subscribe to It's Up Here. And here's another video.